Hello and welcome back to the video series Deep Learning for Teens. In this video, we'll be building an artificial neural network for the MNIST dataset. Before we begin, I highly recommend watching the previous two parts in this series. In part 3, I went over how an ANN, or artificial neural network, works. Part 4 is essentially just a continuation to part 3, but it specifically focuses on how an ANN is trained. If you don't understand the fundamentals of an artificial neural network, then these parts will be very helpful for this video, as this video essentially builds on them. Now without further ado, let's begin. To begin, you need to go to the following link, which will be in the video description. And once you are here, you need to go up to the File menu in the top left, and click Save a Copy in Drive. This will create a copy of this notebook in your Google Drive, and you need a Google account to do this. Now once you are here, you can click each of these code cells and click the delete icon on the right. And we'll be writing our own code, and this is why we can delete all of these code cells. And once we are done, we can go up to the top and click this text cell, which is the part 1 for importing libraries. Now we can go up here into the plus code button and click it, and this will insert a code block right below the text cell. Now we can begin by importing TensorFlow, and we will do this by writing import TensorFlow as TF, and this TF prefix is very common across all TensorFlow applications, and will allow us to refer to TensorFlow as TF rather than TensorFlow, letting us save a lot of text. Now we can write import TensorFlow datasets as TFDS, and this module or library will allow us to import MNIST later on. Now we can click this text cell, which is part 2, loading the dataset, and once again insert another code block. And now we can list the variables we will need, which are dataset train, dataset test, and dataset info. And we will now load the MNIST dataset. So we can write out MNIST here. And now we need to specify just a few more parameters. So first we put a comma, and we are now going to specify how we want to split our dataset. So we're going to write split equals, and we are going to split it into a training set and a testing set. Now we can go to the next line, and we are going to be shuffling our files. And so we can set shuffle files equal to true. And for the last two, you do not need to understand these as of now, but we're going to be setting as supervised equal to true, and with info equal to true as well. And that's it for this code block. And so now we can go down to part 3, click the text, click plus code. And here we're going to be normalizing the images in the dataset. I have previously explained what normalizing is, but I will explain it again once we finish writing this code. So we are first going to define a function to normalize our images. So we are going to have an image input and also a label input. And we are going to be returning our normalized images. And so we are going to write this out. And what this is essentially doing is taking all of the pixel values in each of these images and dividing them by 255. And what this is doing is making the values, instead of making them from 0 to 255, the pixel values are now from 0 to 1. And this is just for TensorFlow to understand them. And now we have to normalize our training set. And so we can do this by writing dataset train equals dataset train.map and our normalizing function. You don't need to understand what this is, but this is essentially just normalizing the images in our training set for us. And now we're going to specify our batch size. And so we're going to make our batch size equal to 64 images per batch. And we have done the training set, but now we have to do the testing set. And we're going to add another code block just to separate them. And we're now going to essentially just put this again, but instead of writing dataset train, we're going to put dataset test. So now that this is done, we have normalized our training dataset and also our testing dataset. And so we can now move on to actually creating our model for us. So we can click this text block, click plus code again, and we are now going to define our neural network model. And so we can begin by writing model equals tf.keras.models.sequential. And inside here is where we are going to define our model. So we hit enter, go to the beginning of the line and hit tab once. And now we can add a flatten layer. And so we write tf.keras.layers.flatten. And now we have to specify an input shape. And so we can put input shape equals 28, 28, since the images in MNIST are 28 pixels by 28 pixels. And we can go to the next line, and we are going to add a dense layer here. And so we're going to write tf.keras.layers.dense with the 128 neurons, and we're going to have an activation function of ReLU. And finally, we are going to add an output layer, which will also be a dense layer. And so we can begin by writing tf.keras.layers.dense, and in this layer, we're going to have 10 output neurons, since there are 10 digits in MNIST, or 10 classes. And this is our entire model for us. And we now need to compile our model. And so we're going to write model.compile. And we're going to be using the Atom optimizer. And so we can write optimizer equals tf.keras.optimizers.atom, and our learning rate is going to be 0.001. And for our loss, we're going to be using sparse categorical cost entropy. So we can write tf.keras.losses.sparse categorical cross entropy. And we just need to specify from logits equals true. And our final parameter is metrics. And so we're going to be writing metrics equals tf.keras.metrics. And here we are going to be using sparse categorical accuracy, which is different from sparse categorical cross entropy, as you will see in a second. So sparse categorical accuracy with quotation marks or parentheses. And that is we have compiled our model here. And finally, we have to train our model. And so we can click this, click plus code, and now we're going to be writing model.fit. We're going to be specify our training data set for training. We're going to be doing 6 epochs, which is 6 cycles of training. And our validation data will be our dataset test. And this is, congratulations, you have finished your first ANN. And so we can go up to runtime and click run all. And this is going to run our code for us. And so right now it's connecting to a server for us. And once it's connected, it should import TensorFlow and TensorFlow datasets for us, which it has done. As you can see by the green check mark. And it has downloaded MNIST for us and put it into our training and testing datasets. And all of our images have been normalized. Our model has been created and compiled, and now it is training our model with our data. And I will see you once this is finished. So our validation accuracy for the first epoch was 95%, and the validation accuracy is basically just how accurate the network was with testing itself on the testing dataset. And this number may be slightly different, and that's okay. And for the last epoch, it was 97%, and this goes to show that our network was able to improve over time and recognize the images in the testing dataset better. And this shows that we built our ANN well because it was able to recognize these images better. In the next video, I will be introducing convolutions, which will lead into introducing convolutional neural networks. I look forward to seeing you there.